Good afternoon, everybody. It's been a very interesting day so far, and I think we're going to solve a lot of problems looking at the presentations this morning. They've mainly talked about carbon. Azotic is Greek for the meaning of nitrogen, and I'm going to talk a little bit about nitrogen in the agricultural world. Carbon that you've been discussing is 77% of the greenhouse gas. We do ignore at our peril the 8% of the nitrogen that's in the greenhouse gas. Why? Because the molecule is 300 times more powerful than a carbon molecule. So roughly it's 8% of the gas, which is 30 times the problem under current usage. As the previous speaker said, in agriculture, it's a tremendously inefficient system, and I'll come on to that. But what we're talking about here is nitrous oxide gas in the atmosphere from nitrogen fertilizers. It's all in a good cause, though. It's to feed us. We all have one thing in common today. We've all had nitrogen for lunch, and you've all got synthetic nitrogen in your cells in your body. Cells cannot live without nitrogen. 70% of the nitrogen that goes into crops worldwide is lost to the environment in some way. This creates tremendous dead zones, and you can see the pictures. I'm not going to talk to them all. You've got a little girl that's on her way to a feeding station, and her mother died, and that is what subsistence farming looks like. The picture was took by Kevin Carter. He's a Pulitzer Prize winner. The little girl was saved, and we could help people in Africa with this type of technology I'll discuss. Food security is coming to governments, but you can see what I'm talking about with the inefficiency of nitrogen. It leaches through the water courses, and some of it volatilizes. We can argue about the numbers. It's between 50 and 70%. It causes algae blooms that has a dead zone. Now, we say a dead zone, what does it mean? It's economic ruin for the shell fishermen and fisheries around the coast, and I work with USDA a lot. They are desperate for a new nitrogen source. So when the algae bloom goes in, you can see the fish, takes all the oxygen out, and it kills the water. Currently, you have a dead zone in the world. If we look at America, Gulf of Mexico, Japan Sea, Baltics, bigger than the UK put together. It's a water quality issue under EU directives. If I talk about Europe, they have to take the nitrates out of the water. If there's nitrates in the water, you get blue baby syndrome. And then we can talk about the air quality later on. We've all seen that, certainly when you watch Beijing, etc. If we didn't have nitrogen fertilizer, you'd need another landmass the size of Russia to feed the planet on the current population. The nitrogen boundary the planet can cope with is 35 million tons. This is all documented. We're currently putting 121 million tons a year into the biosphere. We only have one planet. And to feed the world as we are now, we really need 3 planets of resources, but I won't get into that. The top picture, there's companies all over the world to feed the growing population, building new nitrogen plants. That is not innovation. New science is the innovation. And to take on a little journey in 2 seconds, in the late 1890s, a guy stood up at the Royal Society in London, William Crookes, and said, we are going to run out of fertilizer, which we were. They challenged the scientists, and through science, they got the Haber-Bosch process, which was made in Germany, and there's a whole history lesson behind that. The Haber-Bosch process is scientifically converting atmospheric nitrogen. The only thing on the planet that can convert atmospheric nitrogen is bacteria. This is done now with rhizobia bacteria. But we're in a perfect catch-22 situation. We either use less fertilizer to save the planet, but we're going to end up starving a lot of people. And you've seen people today like Autodesk, the new future. But we have to feed people if we're going to have this explosion over the next few years. So, as I said, the only other way other than bacteria is when lightning strikes, you do get some atmospheric nitrogen fixed. What we've done is looking at giving nature a helping hand, is to take some bacteria from a food-grade crop, which normally sugarcane, so it's a food-grade bacteria, make it into a liquid and a freeze-dried coating. When we apply this food-grade bacteria to a coating, it gets into every crop that we've tried. It's been in field trials. And currently, we are fixing nitrogen in any crop we've worked on. We see this as giving nature a helping hand. I've been told to stop, so I'll stop at that. Quickly, the team is there. It's come from Professor Cocking from Nottingham University. The partners we're working with are international. We will be commercial in 2015. And the key points are we're not looking for cash. I've raised the funding to take us through to 2016. It's unique to us. It's globally patented. We're filing more patents. And it will affect everybody on the planet. Thank you for your time.